All right, guys, so we're going to go ahead with 11 through 15. And we are ready for this, ladies and gentlemen. So, it's still our same EMI passage where we're looking at assumptions and predictions. So we read the question. We circle the KTs in the answer choice. And then we go back to the figure or passage. And we match. Okay. Which of the following statements is best supported by the results of experiment 1? So I'm going to be looking at experiment 1. Launch velocity increases as the mass of the projectile increases. Launch velocity increases as the mass of the projectile decreases. DOP increases and DOP decreases. So we have launch velocity and mass this way or that way. Then we have DOP and LV both this way or that way. So we're going to be looking at the graph. Experiment 1. I'm going to look here. The results are shown in figure 2, so I'm going to look here. Now this is launch velocity versus DOP. So the first thing I can do is cross off A and B because they don't mention DOP. Now let's see what happens. Is it increase, increase, or decrease, decrease? Now the direction of the graph is this way. So anytime that you see the direction of the graph, if you see a graph and it's this way, that's called a direct relationship. And so both of the arrows would be going the same direction. And for this one, it's up. This arrow is pointing upward, so that's an increase, increase. So we need to find increase, increase. That is 11. Okay, so the increase, increase, if the arrow points up, that's what that means. If the arrow points down like this, then that is an increase, decrease relationship. And that's not what we have, but this is what we have. All right, number 2. And by number 2, I mean number 12. It's just number 2 on Canvas. Based on figure 2, which of the following is true? Oh, so we just went over these key terms, and this is something you need to know. You will need to know direct and indirect with graphs. Direct means they both point the same direction. Indirect means when one goes up, the other goes down. So, and then we know our key terms from the graph are DOP and launch velocity. So we are going to look at this question here. So as launch velocity doubles, DOP also doubles. We can cross off both of these because they don't talk about the relationship. And as a strategy, these two questions are almost identical, so it's going to be between A and B. Now again, the graph is pointing up, which means it is a direct relationship. So the answer is A. All right, 13, based on figure 3. So I'm going to head to figure 3. Which of the following statements about B4C and SIC is true? So that means I am looking at B4C, which is this line, and SIC, which is this line. Okay. DOP and density. So at a given areal density, so do you see how again in question 13 these two answer choices are the same? They look almost identical, so I can cross off A and B, so that's a strategy point. Now at a given areal density, B4C yields a greater DOP than SIC. At a given areal density, B4C is lower. So which one has a higher density? Which one has a lower density? So the line here, SIC, is above B4C. So that means that SIC has a higher DOP. So that means that my answer is D for 13. All right, number 14. Which of the following statements is most consistent with the results of experiment 2? I'm going to flip to experiment 2 real quick so I know where to look. And then it'll say the results. Figure 3. Okay, so I'm going to be looking at figure 3 for experiment 2. Now, DOP is independent of ceramic material used. Different ceramic materials yield different DOPs at the same areal density. As areal density increases, I'm sorry, I have not had caffeine yet today. As areal density increases, DOP increases. As areal density increases, DOP remains the same. So, this is where we're actually going to find our first exception to our strategy rule, right? So as areal density increases, DOP increases. That's not true because the graph goes in the wrong way. As areal density increases, DOP remains the same. We know that that's not true because the graph isn't flat. So this is our first exception to our strategy rule, although that maybe happens 1% of the time. You'll see that maybe 2 more times this quarter where those aren't the actual answers. Now, DOP is independent of ceramic material used. This obviously isn't true because the DOP is changing. Now, different ceramic materials yield different DOPs at the same areal density. So, I'm going to go to an areal density here and see how these have different DOPs. So that means that B is my answer because it's supported on the graph. And you would do something like give an example, okay? So, at a density of 12.5, each material had a different, that's supposed to say different, but I ran out of room, so different Y value on the graph. That's something that you could say on your ACT corrections to get that done. Which of the following statements about AL2O3 and TIB2 is best supported by figure 3? So, we're going to go back to here, figure 3. And TIB2 is this one. And AL2O3 is this one. It's already a black line, so I don't have to hide it. Now, ALT yields lower DOP. Well, we know that's not true because the line is higher. And now we can go back to our strategy question. AL2O3 yields higher at the same areal density. So, at 12.5, AL2O3 is 4, and TIB2 is 1 point something. So, we'll say 5, even though it might not be the middle. At a density of 12.5, AL2O3 is at a DOP of 4, where TIB2 has a DOP of 1 point. That looks like pop. DOP of 1.5. That's what I would put in my ACT corrections. And that's your whole standard for this one.